Right. We're going to use this class interval and frequency distribution to answer these following questions. That is mean, mode, median, and standard deviation, and then answer what is the class size of this distribution. So the first thing we do is to put the formula for mean. Remember that mean is S bar. So it is equal to summation Fs divided by summation F. So having known this formula, you can see that what we need in our table is F, X, and the summations. So we already have F on our table. So what we need now is X. And how do we get this X? X is the midpoint of this distribution. So from the class interval, we add all these rows in the class interval and then divide them by 2. So when you divide this, you have 28 and 25. So comparing this 28 and 25 in our class interval, you find out that the first row that we have 28 is looking at how the number is working. You see that it's subtracting 1 1. So since we have 28 25, so from here 23 you have 22 19 16 13 4 and 1. So these are the midpoint. So to get the midpoint, always add the two numbers in the class interval and divide by 2. Then for Fs is multiplication of frequency and the midpoint. So I have 28 times 28 and all that. So multiplying frequency and the midpoint, you get the Fs. So after getting all these values, the next thing is to sum all the values on this Fs. That is the summation Fs and summation F. So let us first add all the values on the frequency. So when you add the summation F is 150 and summation Fs is, when you add everything here, you have 2829. So having known all this, to compute mean will be very easy. So what we need is just to do substitution. So have that S bar is equal to 2829 divided by 150. So when you simplify this, you have that your mean is 18.86. So because we want to approximate this to the nearest, maybe to 1 decimal, so I'll have 18.9. So this is our. We are supposed to find the mode before the median from the question. But let us find the median. So to find the median, we need cumulative frequency on the table. And to get cumulative frequency, remember it is from the accumulation of all the frequencies. But the class interval given for this question is arranged in descending order. That is from the highest to the lowest. So in that case, we'll start from the lowest to assign the cumulative frequency for each of the row. So for 0 to 2 class interval, frequency there is 1. 3 to 5 class interval, frequency there is 11. So for us to assign cumulative frequency for class interval of 0 to 1, go to the frequency. What we have there is 1. So 1 plus nothing is 1. So that becomes the cumulative frequency. So the cumulative frequency we'll write is now 1. So let us do it together. So I have 1 plus nothing is 1. Then 1 plus nothing is 1. 1 plus 11 is 12. 12 plus 7 is 19. 19 plus 10 is 29. So this is how you continue to add it and get all the cumulative. Then the last cumulative frequency is 150. So it must be equal to summation F. Then let us now put the formula for median. So this is the formula for median. To explain all these parameters, L sub 1 represents the lower class boundary of the median class. And then N over 2 is the summation of the frequency divided by 2, which is 75. That is dividing 150 by 2 to give 75. Then the next is CF, which is cumulative frequency of the pre-median class, which is class before the median class. F is the frequency of median class, and C is class size. So having seen this, LCB is needed on the table, and LCB we can get it from the class interval. So from the lower class limit of class interval, remove 0.5 from 27 to get 26.5. This is how you will do for others and be getting all these values. Then N over 2 is 75. We can find it in the cumulative frequency under 77. So this becomes our median class because 75 is found in 77. So having known the median class, let us compute the median. L1 is lower class boundary of the median class, and that is 17.5. So we use L1 for 17.5, then N over 2 already given 75. Cumulative frequency, which is CF, is 58. So after substituting all of this value in our formula, the next thing is to simplify all these. 75 minus 58 divided by 19. So I have 17.5 plus 17 times 2 divided by 19. So when you multiply this 17 times 2 divided by 19, I have that my median equal to 17.5 plus this 1.7895, which will give me 19.29. So this is the median. So we have already computed a mode in our previous video, but we will still look at it also. Thank you. So stay tuned for the mode. So you can see that I decided to make video for median before mode because there is a mistake on the cumulative frequency for this mode table. So please ignore the cumulative frequency you will see on this mode table because it is wrong. I didn't consider the arrangement of the class interval, that is the descending order of the class interval. So ignore the cumulative frequency, though it will still give us, it can still help us to get the modal class, but if assuming I'm calculating something like median, it cannot help us because the arrangement, it did not tally with what is supposed to be. So having know this now, let us compute mode. So this is the formula for mode. So L1 means lower class boundary of modal class. Then changing 1 means difference between frequency of modal class and premodal class. Then changing 2, difference between frequency of modal class and postmodal class. So you can see that LCB is needed in this table. So for us to do that, let us compute cumulative frequency, because the cumulative frequency will help us to know the modal class. But remember what I told you, I didn't consider the ascending order or the arrangement of the class interval. So I started from the highest to assign the cumulative frequency, and it is wrong. I'm supposed to start from the lowest. So please ignore this cumulative frequency. If you want to use cumulative frequency to calculate anything, it's supposed to be from the lowest to the highest, since it is in descending order. So but all these values for cumulative frequency, they are not needful, or we can use it to find the modal class, because to get the modal class we really need to know where the class boundary. So let us get the class boundary. So subtract 0.5 from all these lower class limits. So if I remove 0.5 from 27, I have 26.5, and so on and so forth. So we'll be subtracting 0.5 from each of them, from each of these lower class limits. Then you get all your LCB. Then for determination of modal class, we have to divide n by 2, and m is 150. Divide it by 2, then you get 75. So we now take this 75 and look for where 75 can be found in cumulative frequency. So we can find it in 92. So we circle it as our modal class. So everything that falls in that column is our modal class. So we can now use it to solve mode. So L1, remember L1 is the lower class boundary of the modal class, and that is 17.5. Then changing 1 means difference between frequency of the modal class and premodal class. That is, the frequency of the modal class is 19 and premodal class is 16 for the frequency. So I have 19 minus 16 divided by. But before then, before we divide, let us find changing 2. Changing 2 is difference between frequency of the modal class and postmodal. So postmodal is 20, the frequency is 20. So I have 19 minus 20 to give me minus 1. So now let us substitute it in this equation, in this formula. So I have 3 plus bracket of minus 1. So that 3 is from 19 minus 16. Remember, changing 1 is 19 minus 16, so it's 3. So now when we now simplify all of this, The class size, okay, we have not put this class size from this class interval.